Completing the square. Why do we even do it? I remember when I was a kid, I used to wonder why get into all these problems of completing the square, of adding something, of taking dividing by a and taking c to the other side and all that stuff. Why do we even do it? I never understood it. I had a very logical mind and somehow I was never explained why it was done. But here I am today giving you a visual representation of why completing the square is necessary and how it makes solving quadratic equations very simple. So just stick on with the video and you'll learn everything about completing the square. You'll actually understand why completing the square is necessary. So let's jump straight into the video. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success to this wonderful video on completing the square. So like I said, this is going to be a visual representation. I'm not only going to solve an equation for you, but also we are going to see it visually and see how completing the square helps. So let's take a very simple equation for you all. X square plus 12x minus 64 is equal to 0. Now as you can see, I have written the quadratic equation in the standard form, which is ax squared plus bx plus c is equal to 0. So here if we remember the steps of completing the square correctly, what we had was that the first step was divide the complete equation by a. So here a was the coefficient of x square, so we see that the coefficient of x square here is going to be 1. So we divide the complete equation by 1, so it remains unchanged. The second step was to divide b by 2. So we are going to, since you remember that a plus b whole square is equal to a square plus 2ab plus b square. So since this 2 is here, that means the middle term is being multiplied by 2. So that is why I'm going to divide by 2, and whatever that b by 2 is, the third step was to add the square of that. So add the square of b by 2. So that's all it entails, and of course we take the c to the other side also because we want the x to remain on one side. Coming down to solve the equation, I'm going to do it visually as well as explain how it is done. So we divide it by a, so the equation remains unchanged, so it remains x squared plus 12x minus 64 is equal to 0. So we have divided the complete equation by 1. So the second step was to take c to the other side of the equation. So what we are going to do is we want 64 on the other side because we are really concerned with x's on one side and everything else on the other. So we are going to add 64 to both sides of the equation. So what we are left with is x squared plus 12x minus 64 plus 64 gets cancelled out, and 0 plus 64 on the right becomes 64. So that's what we get, and let's do it visually also so that you understand why we are doing it and what we are doing. So let me draw a square for you here. So what we are doing is we are making a square. Now I have to get it really perfect and make sure that it really does look like a square. Well, that looks more or less correct. And what I'm going to do is, so this let's assume that this is a square which has a side of x. So since you find out the area, so the area is x into x, which is x squared, and that's what the term that we have here. So next we have to do is add 12x to it. So we'll have to draw a rectangle which has the same length as the previous square, and it should have a breadth of 12. So I think that should be the same length. Okay, so let's say that the length here is x and the breadth is 12. So that's our 12x, and that should be equal to 64. So let me draw another rectangle here. Now without going into So say it's something like this. So I won't really give the dimensions to it, but let's just say that the area of this square is 64. So that's what we have here, x squared plus 12x, that should give us equal to 64. So that's our visual representation. Now the third step was to divide b by 2. Now what really are we trying to do by dividing b by 2 is that we have to divide 12x into two parts. So to do that, let me draw a line across this so that we can divide it into two equal parts. Okay, so that looks just about right. Okay, so we have divided b into two parts. So once we have divided b into two parts, what I'm going to do is I'm just going to rearrange this a little bit. So to do that, let me just erase these lengths for a moment so that we don't have any confusion left. So since the length of this was, sorry, the breadth of this rectangle was 12, let us now assume that it's 6 on both sides. So as you can see from here that the 12x, when it is divided into two parts, or when we divide b by 2, so if b is 12, then the half of 12 is 6. So the third step was to add the square of 6 to both sides of the equation. The square of 6 is going to be 36. So why we will do that, let me see, but before doing that, let me take these two rectangles that we have got to the other side. So I'm going to just take this rectangle, the half of this rectangle, and combine it with this square that we had, and this rectangle we are going to turn it over. So I'm going to rotate it by 90 degrees. So and I'm going to join it here. Yeah, this length was perfect. So we've got it right here. So that's how. So we have taken the 12x and combined it into the initial square that we had, and what you can see it very properly now and very clearly is that we are left with this small part, right? This small part which is not covered. So we will have to add something to this equation to make it a complete square, and that's why this method is called completing the square method. So that's it, we have added this. So but since we have added this to this part of the equation, we must add the same to that part of the equation also. So let's say we draw another rectangle here which completes the square, makes this a square also, and let's say that the area of this rectangle is 36. So now all we have to do is we just have to take the square roots of both the sides and we get the answer. So now since we have seen that the square of 6 is 36, we are going to add 36 to both sides of the equation. So we get x squared plus 12x plus 36 is equal to 64 plus 36, which gives us 100. And since x squared plus 12x plus 36 is nothing but the square of x plus 6 is equal to 100. Now let me go down a bit and take this up so that we can solve it in a better way, more clearly. Okay, so now we are going to take a square root of both sides of the equation. So if we take a square root of x plus 6 whole square on the left hand side, we are just left with x plus 6, and the square root of 100 is going to give us 10. So it could be either plus 10 or minus 10. So let's divide that into two parts now, since we are coming to the solution. So let's say x plus 6 gives us 10. That's one part of our solution. Or we can also say that x plus 6 is equal to negative 10, because the square root of 100 could be positive 10 also and could be negative 10 also. So now getting to the solution, we subtract 6 from both sides of the equation. So subtracting 6 from this equation, we get x is equal to 10 minus 6 gives us 4, or that's one value of x, or subtracting 6 from both sides of this equation here, we get x is equal to negative 10 minus 6 gives us negative 16. So those are our two equations that we have, and so just let's substitute these values of x and see what answer do we get. So if we see, we've got if we substitute 4 into this equation, the equation on top here, if we substitute 4 into this, so the square of 4 is 16 and 12 times 4 is 48. So 48 plus 16 gives us 64, and 64 minus 64 is 0. So yes, indeed, x plus 4, x is equal to 4 is indeed a solution for this equation, or x is a root of this equation, or we also say that x is a 0 of the equation. Now taking the other side, where x is equal to negative 16, so that we see that the square of negative 16 is 256, and negative 16 times 12 gives us negative 192. So 256 minus 192 will give us again 64, and 64 minus 64 is 0. So that means x is equal to negative 16 is also a root of the equation. So that's it, guys. So I'm sure you must have understood how we complete, why exactly we complete the square, because we have been doing it for very long now without really understanding why we complete it. But since this visual representation here, that even if we add both the terms together, we are still left with this small thing on the square which we hadn't counted out, and we had to add that to both sides of the equation to make it a complete square. If you haven't yet subscribed to the channel, you should subscribe to it right now. Please like and share the video with your friends, and we are going to come back with more interesting videos on various other topics. And in case you have any doubts, you could send in your queries to me in the comment section below, and I'll surely get back to you. And stay connected. God bless you. Study hard. Do well.